This
So
conference will now be
we'll be
recorded.
understanding about the list method. Okay, so what we'll be understanding today? We will be understanding about the list methods, and you will also be understanding about the tuple method. Okay, so tuple method. Sir, why you are calling them as methods actually? So whenever you are saying a method, so method is something similar to a function, not same exactly. It is something similar to a function, but it will be declared inside the class. Okay, so what is method actually? Method is something which is declared inside the class. Okay, so inside the class, if you have a function basically, so if you have a function, so that will be declared, or that will be called as a method. That will be called as a method. Okay, so that's the basic idea. Okay, so what I'm talking about, so when you have a function, see generally how you create the function, you create the function saying def function name, yes or no. So you'll have the arguments, you'll have the statements, blah blah blah, right? Now this is called as a function. Now if the same thing, if I put it inside the class, inside the class, let's say list. So what is list actually? List is a class. What is list? List is a class. So inside that list you will have some same functions, but what we call them, we call them as methods. We call them as methods. So what is a method? Basically a method is something which is declared inside the class. It's a function. The basic terminology will be a function terminology only, but it will be declared inside a class. That is what the major difference. Okay, now as I told you, list is a class, tuple is a class, dict is a class, str is a class. What are all these? All these are classes only. Why, sir? Why everything is a class? Because Python is object-oriented programming language. When I say any programming language, object-oriented, what is the original meaning? The original meaning is everything is object. Everything is object. So without a class, there won't be any object available. So without class, there won't be any object available. Now, you all belong to which class? You all belong to a student class. Yes or no? You are all objects belonging to student class. Just imagine if student class is not there, what I will call you? Got my point? So that is why object, student object. So I belong to a trainer object. I belong to a trainer object. So in that way. Yes, clear with the points? Okay. Now today we will talk about the list method. So first of all, what is a list? List is a collection of list is a collection of heterogeneous elements. List is a collection of what? Heterogeneous elements that will contain, that will even contain duplicates, that will even contain duplicates. Getting my point? So what is list basically? List is a collection of, list is a collection of heterogeneous elements. List is a collection of heterogeneous elements. List is a collection of what? Heterogeneous elements. So what do you mean by heterogeneous? Heterogeneous means all types of elements. Heterogeneous means what? Heterogeneous means all type of element, all type of element, all type of element. Got it? All types. All types in the sense, what are the types that you have? You have integers, you have floats, you have uh, uh, basically string, everything. Yes. Okay. So it's a collection. Basically, list, tuple, all these are called collections. Okay. So you are habituated to the word data structure, but data structures here are nothing but the collections only. Yes. Okay. So it can contain all types of elements. It can contain elements using using index. Yes or no? Using index. So for example, we will talk about creating a list. So we'll talk about creating a list. Okay, so we'll talk about creating a list. So whenever I'm talking about a list, so generally this is list, isn't it? So all types of elements I can have. Now I will have integer, I will have float value. Okay, I will have float value. I can have a string. Yes, I can have a string. I can have a Boolean value. Okay, I can have a Boolean value. I can have none value. Yes or no? I can even have a list. I can even have a list, no problem. So, for example, I want a list inside this. Okay, I will say 5 comma 6 comma 9. Okay, 5 comma 6 comma 9. Okay, so I can even have duplicate elements. I can even have duplicate elements. Yes or no? I can even have duplicate elements. Yes, getting my point or not? So now, what is indexer? Basically, index means, now what is the first element? First element will be, okay, let me just make some distance between every element so that it will be clear for us. Okay, now what is this element, sir? This element is 0th element. This element is first element. This element is second element. This element is third. This element is fourth. This element is fifth. This element is sixth. This element is seventh. Right? Okay. Even you can have negative indexing. Even you can have negative indexing. So minus 4, minus 5, minus 6, minus 7 and minus 8. Yes? Okay. Now let's understand these two. So let's understand these two elements. Now if I have to access, one second. Okay. So if I have to access, hello. Okay, how can I access hello? Okay, first of all, how can I access this 4? Okay, how can I access this 4? I can access this 4, okay, by using index 0. By using index 0. Yes or no? Yes, by using index 0. Okay, now if I want to access this, how can I use? I can use index 2. If I want to access this, how can I access this? By index 5. Yes, so technically this is the thing. But in order to work it with a program, what I can say, I can say, what I can say, I can create a list. I can create a list. Okay, now this is my list. And I have to assign. I have to assign. So without assigning, we cannot access the values. So that is why we are assigning. LST is equal to. Now access the first element. LST of 0. LST of 0. Did I access it? Yes or no? Did I access it or not? Okay. Now access hello. How can you say? LST of 2. LST of 2. Now you went there. Okay. So now what you got here? You got hello. You got hello. Right? Okay. Now I'll say LST of, now I want 569. So I want 569 means 0, 1, 2, 3, 4 and 5. I'll say 5. Okay. Now if you observe, LST of 0 is a single element. LST of 1 is also single element. LST of 3 is single element. But what about hello and 569? They are again a collection. They are again a collection. So what we can do, suppose I want to access this E. If I want to access that E, what I can do, I can say LST of 2 of, this is called sublisting. Okay, what is this called? Sublisting or subindexing. Okay, so 2 of, what is this again? This is going to be 1. This is going to be 1. Understanding my point? Yes or no? Yes, did you get E or not? How did you get E? Because that hello is again having index. Now tell me, how do I get 9? How do I get 9 here? Tell me. Very good. LST of 5 of 2. LST of 5 of 2. So now you got 9. You got 9. Okay. Understanding my point? So this is how you can access the element. How you can access the elements. If multiple elements are there, then also you can access. So how you are able to access? Hope you understood it. Okay. So this is what 0, 1, 2, 3, 4, 5, 6 and 7. So we'll try to focus more on positive indexing rather than negative indexing. Negative indexing is like a bit confusing at times. Okay. Now what is this hello here? Hello is again H, E, L, L and O. Where is it available? It is available in LST of 2. Okay. LST of 2 of 1. LST of 2 of 1. So LST of 2 what is containing? HELLO. In HELLO you have this E. You have this E. Where is E? E is available in 0, 1, 2, 3 and 4. It is available there. Is my point understood? So LST of 5. What is LST of 5? LST of 5 is 569. So how can I represent 569 here? So 569 I represent something like this. Yes? Yes or no? Okay, again what is this? 0, 1, 2. Now you are accessing the second element. Hope the points are crystal clear. Yes or no? So in this way you are going to deal with the list. You are going to deal with the list. Clear with the idea, everyone? Yes or no? Okay, just the basics I want to give. Okay, now what is the property of the list? List is mutable. List is mutable. List is mutable. Mutable in the sense a list is mutable. List is mutable. Mutable means what, sir? That is a list can be updated in size. Updated in size. And its elements also can be updated. Updated in size means increase or decrease the elements. Increase or decrease the size of the elements. We can do that. Okay. So we can even have some changes. Okay. So updated in size and content. Updated in size and content. Okay. So the updations can take place by using the list class methods. Updations. The updations can take place. The updates, I will say. The updates can take place by the help of the list class method. Okay. Now, what are the methods that are there that we should know? So there is a simple way to get the list of methods. Okay. To get the list of methods, I can simply say dir of LST, dir of LST. So simply dir of LST, I will get the list of the methods. Did I get all the list of the methods? Yes or no? Did I get the list of the methods? So simply, so you don't have to remember and all. Okay, simply say dir of LST. What is LST? LST is the object. LST is the list object reference. Okay. So if you say dir of LST, you are getting the list of all the methods. Okay, sir. Fine. Now I want to know what append will do, what clear will do, what copy will do, and what is the signature that it contains, what is the format that we have to use and all we should know. So in order to know that, so simply I can say help of LST. What I said here? Help of LST. So once I say help of LST, so if you observe here, we have all the methods with the information also. Did we have all, I mean, do we have all the things or not? So I can get all the information. I can get all the information. Did I get that? Yes or no? No need to hardly understand, hardly work for it. Directly you say help of this, you will get it. Why to have our own definitions and waste our time? Yes? Okay. Now append. So what is our first method? Append method. So what append is saying? So self you can take off because what self will say? It is a method. It is an instance method. So we talked about instance methods in classes and all. But what is important sir here? Object is important. So what is this method going? So we'll go one by one. What append method is going to do? It will append object at the end of the list. Append means what? Simply add. Add object at the end of the list. Add object at the end of the list. Am I clear? Yes. Okay. Now how to use this? I will say LST. So what is LST for me? LST is this. Yes or no? What is LST? LST is this. Is that clear? Yes, LST is this. Now append. Append means adding the object at the end of the list. So how can I add, sir? I will say LST dot append. Append an object. Append an object. Now I will say false. You append false. Now see what happens with the list. What happens with the list now? The list will have these values. Yes. What the list contains? What the list contains? One additional value list contains or not? What is that additional value? False. Where it added? It got added at the end. Because what is the append? Append is adding something at the end. Adding something at the end. Am I clear? Yes? Okay. So that is how you can go for it. Okay. Then clear. Then what? Clear. So what clear will do, sir? Clear will remove all the elements. What clear will do? Clear will remove all the elements from the list. What clear will do, sir? Clear will remove all the elements from the list. What clear will do? It will remove all the elements from the list. All the elements. Making it empty. Making it empty. Okay. So now let's create, or let's go for the same thing. LST. Okay. LST. So what is LST now? LST is going to be having one more value, no? So what is that one more value? One more value is false. Okay. Now what I will do? I will say LST dot clear. LST dot clear. So once I say LST dot clear, now tell me what happened. Okay. Now tell me what happened. The LST, it became empty. The LST became empty. Yes or no? LST became empty. Why, sir? Because you used clear method. You used clear method. What a clear method will do? Clear method will clear all the elements. Clear all the elements. Got it? Getting my point? Got it? Okay. So that is the second method. Okay. Now coming to the third. Third method is the copy method. Okay. So whenever we talk about copy, so actually we will have two types of copies. Okay. Actually what we have? Two types of copies. So before going to copy function, copy method, we will talk about copy styles. Okay. So Python copy styles. Copy styles. Okay. So we'll talk about the Python copy style. One is deep copy, right? One is shallow copy. What is the first type of copy? Deep copy. What is the second style of copy? Shallow copy. So deep copy and shallow copy. So what is the first style of copy, sir? What is the first style of copy? Deep copy. What is the second style of copy? Shallow copy. Okay. Then what is this deep copy? Okay. First we will understand the example. Then we'll write the definition. That will make it easy. Okay. Now let me create a list of, let's say, 4 elements. Okay. I'm creating a list of 4 elements. How many elements are there now? 4 elements are there. Okay. Now what I'll do is I will create one more list. Okay. What I said here, LSTC is equal to LST. Means what I did here, I did a deep copy. Right? What is deep copy? Okay. Now, for example, LST. LST is now this one, isn't it? So what is LST? Okay. Let me run this first. And what is LST now? LST is these values, isn't it? What is LST, sir? LST is these values. Okay. Point number 1 clear? Okay. Now what we did? We did deep copy. So after doing deep copy, What happened to LSTC? Copy means what? Same elements only, no? Yes or no? Copy means what? I'm copying one list to the other. Copying means same elements or not? Yes or no? Oh, now, now I will say LST dot append. LST dot append. I will write Java. Okay. Now tell me what happens. Java will be added at the end. Fine. Super. Right. Okay. Now without making any changes, I will say LSTC. Now tell me what happened. Now tell me what happened. I said LSTC. Now tell me what happened. 4, 5.6, hello, true, and Java. Did I make any changes to LSTC? No, I made changes to the original copy. But the changes got affected to the duplicate copy also. Now this is original. This is duplicate. But making changes in the original is also affecting the duplicate. Yes or no? Give me a point. That is deep copy. Now, if anyone asks you what is deep copy, what you'll say? The changes made in the original, the changes made in the original also affects the duplicate. Also affects the duplicate. The changes made in the original also affects the duplicate. Duplicate. Also affects the duplicate. Yes or no? Am I crystal clear or not? Yes. So the changes made in the original also affects the duplicates. Clear or not? Yes. So this is the proof. Yes. Okay. Sir, make changes in LSTC. Okay. Now let's make changes in LSTC. LSTC dot clear. Okay. LSTC dot clear. Now what happens with LSTC? Tell me. It will be cleared up or not? It will be cleared up or not? Okay. Super. Now let's see what happens to its original. What was its original? LST, no? What happens to its original? It also became empty. Why, sir? Because it's a deep copy. Because it's a deep copy. So making changes to the original will change the duplicate. Making changes to the duplicate will change the original. Same thing, same thing. Vice versa, they say. Yes or no? Understood my point? Okay. Now, what is your guess? What may be shallow copy? Yes. What may be shallow copy? Shallow copy. Shallow copy is like opposite. When you are making changes to the original, no changes will be made to the duplicate. When you are making changes to the duplicate, no changes will be made to the original. That's it. Quite opposite. Yes or no? Okay. Tell me the definition. The changes made to the original will not affect duplicate, and Vice versa means vice versa means changes made to the duplicate will not affect the original. It is as simple as. Yes? Okay. Now let's go with the same logic and see the difference. Same example, we'll make it fast and easy. Okay, now this is the list. Okay, how we'll make a shallow copy, sir? Shallow copy is done by using the copy method. By using which method? By using the copy method. By using which method, sir? Copy method. So it is done by it is done by using which method? Copy method. Using the method copy. Okay, copy we don't have to pass anything. Append we passed something, no? So here we don't have to pass anything. Yes. So what I can say for a shallow copy, tell me. Shallow copy, what I can say? I'll say LST dot COPY. LST dot. So make a copy of LST and store where? And store in LSTC. And store in LSTC. Got my point? Okay. Now let me run this. Now let me run this. We made a which copy? Shallow copy. Okay. Then I'll say LSTC. Now true and all, fine. LST dot append of Java. LST dot append of Java. So you are making changes to original or duplicate? Original. Okay. Now let's see the duplicate value. So in duplicate, what is there? Java is there. In duplicate, Java is there. So in original, okay, one second. Yeah, one second. So lst.java. Okay, right. I think I need to do it once again. So now lst, you have these values. Clear? Okay. You are making a shallow copy. Clear? Okay. Now let's say, okay, LSTC. LSTC means obviously you will get the same values. Yes or no? Okay. Up to now understood? Okay. Now I am making changes to original. Means I am adding Java. Okay, super. Right. Next, I'm saying LSTC. Do you find Java there? Why? Why not? It's a shallow copy. Shallow copy means making changes in the original will not affect the duplicate. Okay? Right. Okay. Now I'll make changes in the duplicate. Okay. LSTC dot here. Obviously LSTC will be empty. Now LST. What is LST containing? What is LST containing? The original list. It is not changed. Yes or no? After append, we did not change it. You are making changes to the duplicate. Duplicate changes will not affect the original. It is as simple as that. Hope you are understanding my point. Yes? Okay. So that's the way. I'm sorry. So that's the way you are making the changes using copy. Using copy. Understood? Copy is clear? Okay, good. Now we will go for the next method. What is the next method, sir? Next method is the count method. So what count will do? Count will count the number of number of occurrences of a value. Number of occurrences of a value. Okay, number of occurrences of a value. So what count will do, sir? It will return the number of occurrences of a particular value. Of a particular value. Got my point? Yes. Okay. List contains duplicate values or not? List can contain duplicate values or not? Yes. List can contain duplicate values. No problem at all. So LST is equal to, okay, for comfort, I will put only numbers. Now I will say LST dot count of 4. LST dot count of 4. Now tell me, what is the total counts? 2. Why? So how many 4s are there here? There are 2 4s. Okay, super. Now LST dot count of 8. How many counts are there? 3 8s are there. Okay, here? Is my point understood? Okay. Then LST of count of 6. How many are there? Only 1. Only 1. Okay, super. Now LST dot count of 5. How many are there? 0. Why 0? Because no 5 is there. 5 is not there, so it is 0. Understood? Count now? Yes? Okay, so that is count for you. Next, extend. What is extend, sir? Extend the list by appending elements. Now append, what append has done? Added single element, added single element. Then what extend will do? Extend will go for multiple elements, multiple elements. Iterable means what? Iterable means a collection, simple. Yes, from the collection, from the collection. So you will have a collection of elements added at the end. You will have a collection of elements added at the end. You will have a collection of elements added at the end. So not one element. So multiple elements you can add. Okay. Now let's take the same list. Hope you are understanding. But you have to practice. Okay. So go home and practice without seeing number method only, no? Method only, no? Which method extend? Method. First one is append. Change in the sense, okay, you want only single number. Huh? You want only single number, all single numbers you want. Okay. Okay. So 4896. So now I will say lst dot extend. I will extend a collection. I will extend a collection. Let's say 1, 2, and 3. Okay. Now I will say lst. Now tell me what happened. Now tell me what happened. You added 1, 2, 3 at the end. You added 1, 2, 3 at the end. So you added 3 elements. What are the 3 elements? 1, 2, 3 at the end. You added them at the end. Is my point understood? Yes or no? So that's how you are looking at the extend. You are looking at the extend. Okay. So extend 4896. Okay, 1, 2, 3. So you extended the list by adding a collection of elements at the end. Append only one element. Extend multiple elements. Clear? Okay. Then we go for the index. Then we go for the index. Okay. So in index, if you observe, these are the default arguments. Actually, if you remember, we talked about the default arguments. What are default arguments? If you don't give also, automatically they will be available. Automatically they will be available. So if you don't give also, automatically what will be available? Automatically these will be available. Okay. So then what index is doing? Return first index of a value. Okay. Now I have to put duplicate elements because I need to show you. So lst is equal to, okay, I'll make it 4. I'll make it 4 again. Okay. Okay. So returns first index of a value. Returns first index of a value. So you are returning the first index of a value. Okay. Now for example, I will say lst of 4. Okay. Now tell me what it does, what it will. lst dot index of 4. Okay. lst dot index of 4. Sorry. So lst dot index of 4. Okay. How many 4s are there actually? How many 4s are there? 3 are there. First location 0, second location 2, third location, right? Yes or no? But what it is giving? It is giving the first index. Where the search started? The search started at 0. Yes? Generally what it is saying, you end the search on this number. But actually what happens is, it will end the search up to the size. Will end the search up to the size. So this number is not considered. What number is considered? The uh, last length is considered. Okay. So if it has to go up to there, it will take a lot of time, right? So it is the default number. That's it. Yes. It will start from where? It will start from 0 and will go on up to this number if you don't give any number actually. But according to the terminology, According to the list terminology, it will start from 0 and it will end at the end of the list. At the end of the list. Okay, so there is no point on this number, no? Is there any point? Is there any point in searching up to that number? So there are only 1, 2, 3, 4, 5, 6, 7 elements. So what is the point in searching 10, 15? No point, no? Understanding it? Okay. Now I can start searching for from 1. From 1. I started from where? I started from 1. So after 1, where is it available? After 1, where is it available? So from 1, it will start searching. From 1, it will start searching. Okay. So it will start searching from, okay. So I will write here, start searching from where? From 0th index. From 0th index, right? By default. Okay. Why, sir? Because here is here. Okay. Next step. Now you are asking. Now you are asking, hey boss, you start searching from the which index? First index. You start searching from the first index. You are asking it. Got my point? Okay. Next. Now you will start searching from 4, comma, len of LST. Yes. You start searching from where? So from 4 to len of LST. Literally, what is the meaning here? The meaning is LST of index. What is len of the list? What is the length of the list? What is the length of the list? Length of the list is 1, 2, 3, 4, 5, 6, 7. So start searching from 0 to 7. So this is always minus 1. Always minus 1. So if you give also, it will be searching from, okay. Start searching from 4th index to 4th index to len of LST minus 1. Okay. So len of LST minus 1. Okay. So that is the point here. Okay. Right. So if I have to tell you what is the length of the list here, 4th index to 7 minus 1. What is 7 minus 7 minus 1? 7 minus 1 is nothing but 6, no? It will start searching from, okay, so from 4, 0, 1, 2, 3, 4. 4, it will start searching from 4 to 6. 4 to 6. 4 to 6. Got my point? Yes or no? So what it is giving answer? 5. Why sir 5? Because from 4 it started, no? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. It started from here. Here 4 is there? No. Next it will go. Here 4 is there? Yes. So it will search like that. Understanding? Okay. Now, if you are searching for an element which is not available, what I'm getting? What I'm getting? 5 not in the list. What do you get? You get an error. What is that error? Value error. What is that error? Value error. What is the value error? What is the value error? 5 is not in the list. So you are trying to search for an element which is not available. Understood index method? Yes or no? Okay. Now next coming to the insert. Okay. Next coming to the which method? Insert method. So what does insert will do? Insert will insert the object before the index. Okay, now this also will, with example we will understand better. Okay, with example we'll understand better. So now let's go for the example. Okay, so list. Okay, so what I'm saying, okay, I'll make it simple again. So 4836. Okay, now I'll say lst dot insert. Okay, insert at 1. Okay, you insert 5. Now tell me what exactly happened over here. Now tell me what exactly happened over here. Read the lines. So read the lines. Insert the object before the index. So where I wanted it to get inserted? Index 1, no? So actually 0, 1, 2, 3. Before 1. At 1 I can say. So you can also say or we can also say insert the element at that index, moving the elements to the right. Moving the elements to the right. So that also you can, I mean, in that way also you can understand. In that way also you can understand. Getting my point? Okay. Now I'll show you technically what is happening in the background. Let me copy all this stuff in your notes so that it will be easy for you. Okay. Right. Going down here. Now, for this a little bit information is required. So now what is list actually? 4, 8, 3, 6. Isn't it? So we said 0, 1, 2, 3. Done? Okay. Now what I said, insert 1 comma 5. Now simply I will say you insert 4 at right and move the elements. Move the element. So that's the logic basically. That's the logic. Okay. Insert object before index. Before index in the sense. So if you are trying to understand this way, what it will do? It will say 4. Okay. So it will who is 8? 1 before that index 5. 8 should not be gone. 8 should be there. It should be there, but it becomes 2. It becomes 2. 0, 1, 2, 3, 6. So 3, 4. Okay, so 3 and understanding. You can understand in whichever way is possible for you. Yes, am I clear? So that is what is insert. Insert. If you want to insert, you can insert that way. Okay, right? Understanding? Okay, next we will talk about the pop. So what does a pop do? Pop will remove the element, remove the elements. It will not only remove, it will return also. It will remove and return. It will remove and return. So it removes also, it returns also. But by default, what it gives you? It gives you the last or it deletes the last available element. It deletes element, last available element. So default index is what? -1. If you don't give any value, it will go for the removal of the last element. Removal of the last element. No, sir, I want to give index means it's up to you. Okay, it will delete the uh, whatever element you want. Okay. Now let's say lst is equal to okay. Now remove last element. Last element. Okay. How will I remove the last element? Okay, how will I remove the last element? Now, for example, if I am saying lst dot pop, no need to say last element and all. Okay, it will automatically remove. So, what it returns? It returns 6. And what happens to the list? It will be 4, 5, 8, and 3. It will be 4, 5, 8, and 3. Got my point? Yes or no? It is returning 6 and last element automatically removed. Yes? Understanding my point? Okay. Now, if I have to make you understand this, let me say again. I'll just increase the font. Okay. What are the elements? Tell me again. 4, 8, 3, 6. We know positive indexing, but I also told you there will be negative indexing also. Yes or no? Now pop, what is pop doing? Pop is taking index value as -1. Means what got removed? 6 got removed. It is as simple as that. Yes, it is as simple as that. Okay. Now LST dot pop of 1. Okay, LST dot pop of 1. Now tell me what happened. Who got removed? So 4583. 4583, who got removed? First element got removed or not? Yes or no? Which element got removed? The first element got removed. Yes? Yes or no? Okay. Returns which error? Index error. When it will return index error, you know, if you are giving something like 5, what it is giving you? Index out of range error. Why, sir? Is 5 available? We have only 3 elements. How can you remove the fifth element? You can't. That is why it is giving you index error. Okay? Right. Next, remove. So what remove will do, you know? Remove will remove the element. Remove the element, not the index. Okay? So pop is taking care of index removal. Yes or no? Pop is taking care of index removal. So if you want to remove, okay, if you want to remove the elements, directly elements, you go for the remove. You go for the remove method. Okay. Now let's say 483 is there. LST is equal to 483. Okay. Now I will say LST dot remove of 4. Okay. Now I will say LST. Now tell me what happened. What got removed? 4 got removed. No, not fourth index. Element 4 will get removed. What will be removed? Element 4. Element 4 is removed. Element 4 is removed. Got it? Yes or no? So that's what the logic. Okay. If you are trying to remove an element which is not available, let's say LST dot remove of, let's say 5. Now what is it giving you? It is giving you value error. What is it saying? X is not in the list. So removing, if you want to remove X, X is not in the list. Okay. So that's what the idea. Okay. So there are 2 more methods. Okay. So these are little bit different methods. Okay. So these 2 more methods, time will not be sufficient. It will take 10 more minutes of time. So we will talk about this in tomorrow's session, and we'll also talk about the tuple methods. Okay, so tuple methods and these 2 methods, these are also important. So reverse method, and you need to understand what is in place. Okay, so there also you need to understand. It will take more time. So that's why we will talk about them in our next session. Okay, so go home. I will send the notes right away. Okay, so I'll put the video also in 1 hour time. Okay, so go home, practice, right? So without seeing, you try to practice once. So then you will get the idea. Okay, so that's what good practice is. Okay, right. Thank you. So we'll meet tomorrow with more discussion. Thank you. Yeah. Okay, Saujanya, hope you understood.
Yes, sir. Clear, sir.
Oh, okay, very good, very good. Okay, thank you. Thank you. Bye.